Hi, everybody. We're going to go ahead and get started. My name's Tim Hendricks. I'm the track host for this session. I'm from Styra and OPA, and so I'm especially excited to host this talk. Reminder, we'll have 5 minutes for Q&A at the end. I'll run around and get you the mic, so the recording will pick up your questions. Also, remember to rate the talk. Go and log into Schedge to go ahead and do that. So without further ado, I give you Ash Narkar. He's going to be talking a bit about policy problems in the data lake.
Hola. Thank you, Tim. So my name is Ash Narkar. I am a software engineer at Styra, and we are the makers of the Open Policy Agent project. And I'm also a core contributor to the project. And so today is special for me because it's my first time speaking at KubeCon. So I'd like to thank you all for sharing your time with me. So in today's talk, I'm going to discuss data lakes, their architectures, and the security challenges that they face. Then introduce the Open Policy Agent, talk about its features, its use cases, and then we'll drill down into a data protection use case. So in today's world, data is king. And so it can be data from your cell phone, your laptop, your tablet. Data is pervasive, it's abundant, and it just keeps on growing. And so this is an awesome opportunity for businesses because now they can use all this data, they can analyze this data, they can draw trends from this data, and they can use it to drive customer experience, and they can also use this data to drive the growth of their companies. And so with data being so critical and so sensitive, it is really important that this data be protected, especially in today's world where cyber attacks are pretty common. And the threat of data breaches is a reality for businesses both big and small. And so with these attacks and breaches, your companies are not only going to get fined, but more importantly, you are going to lose the customer's trust. And so we need a really good solution to solve this important problem. And so what companies normally do, they are going to build up a data lake to store their data. And so basically, what is a data lake? And so a data lake is nothing but a large storage repository which can store massive amounts of raw data in its native format until it is really needed. And some of the features of data lakes are like centralized content. So you can store your data from different sources in this data lake. And once it is stored, you can then later use it for applications like machine learning, for analysis, whatever you choose. And since this data lake is like a central store for your entire division or for your entire unit, it is capable of significant scalability. Data lakes can support multiple data types, so you can have structured, semi-structured, unstructured data can all be put inside your data lake. And finally, you have resource optimization. So by decoupling the compute from the storage, you can scale both independently. And so now you can store your data in a cheap manner in your data lake as compared to databases. And so you have all this data, storage is cheap, but data in its raw form is rarely meaningful and cannot be used by applications for immediate consumption. And so you do not want to end up in a situation where you have this massive amount of data which you are just holding, and you can't use any of it. And the one which is even useful for you, you've made it difficult to access. And so to solve this problem, companies typically build out a data lake platform in which you're going to ingest your data, you're going to store it, and then make it available for analysis in the future. And so this figure illustrates a typical workflow for a data lake platform in which you use Kafka for ingestion, you can use Ceph for storage, and then you can use Elasticsearch for analysis. And so in today's talk, we are going to focus on 3 components: Kafka, Ceph, and Elasticsearch, and the security challenges that all these face. And so today we are going to provide you a unique and a revolutionary way in which you can enforce custom security policies in each of these systems in a flexible and a powerful manner. So let's first look at Kafka. Kafka, as you guys may know, is a distributed streaming platform. It can handle trillions of events in a day. It's typically used for building streaming data pipelines, which can transfer data between different applications, and also for building streaming data applications, which can transform or which can react to streams of data. So the authorization model in Kafka is access control lists. And a typical Kafka ACL statement says that a principal P is allowed or denied to perform an operation O on a resource R. And so ACLs are simple and they are straightforward, but they are limited by their scale, their flexibility, their expressiveness, and their management. And so imagine you want to enforce policies such as consumers should not be reading from topics which contain PII, or your personally identifiable information. Or you want to restrict users from writing to topics which have high fan-out. If you try to enforce these kinds of properties or policies using ACLs at scale, given their limited expressiveness, it's going to be a management nightmare. And so the question is, how can you enforce such security policies in Kafka? And more importantly, who is going to do it? Ceph. Ceph is a distributed storage system that provides block storage, object storage, and file system storage in a unified system. The security protocol in Ceph only applies to the Ceph clients and the Ceph servers. And so it's the client's responsibility to provide access control for the data that is stored in the object store. And so imagine you want to enforce policies which are based on a user's location, such that the user can only be allowed access to buckets which are in his same location. Or you want to have access control policies based on a user's business unit, his department. How are you going to enforce such policies where you don't even have a security framework in Ceph? And again, more importantly, who is going to do it? And lastly, we have Elasticsearch, which is a full-text search and analytics engine. It's capable of storing, searching, and analyzing vast amounts of data in almost real time. So again, the security in Elasticsearch is more of a premium feature, at least the authorization. And so the user, it's an exercise left for the user to implement access control policies. And so imagine in Elasticsearch, you have a patient's, you have an individual's PHI, which is the protected health information, and you want to provide secure access to that information based on, say, a user's role or some attribute based on the user. How are you going to enforce that kind of attribute-based policies in Elasticsearch? And who is going to do it for you? And so now you have these three distinct systems, each in their own different programming languages, each having different security requirements, which keep on changing over time and hence become difficult to predict. And so how are you going to enforce policies in each one of them without hard-coding that policy in software? Or how are you going to enforce policies in each one of them without tightly coupling the underlying system to the policy enforcement? And more importantly, how are you going to achieve these two objectives without compromising on speed and performance and in a really expressive manner? And so my question for you is there a solution that can provide uniform policy enforcement across the stack in all these systems in an expressive and powerful manner? And luckily, the answer is yes. It's the Open Policy Agent. And so with Kafka, you can take the Kafka's authorization interface, and you can plug in OPA with that, and you can enforce policies such as don't allow certain users to write on high fan-out topics. In Ceph, you can integrate OPA with Ceph's object gateway to provide access control over the object store. And we will look at this use case later in detail. And finally, for Elasticsearch. So this is where OPA does something special. This is like an experimental use case for OPA that we have. And so in this use case, instead of OPA giving you a decision back, OPA will return to you a set of conditions which you can then translate into Elasticsearch queries and then enforce them on the database. And so now let's look at what is OPA. Just a quick show of hands. How many of you have heard about OPA? Wow, that's a lot. And how many of you are actually using OPA? OK, that's helpful. Thank you. So OPA is an open source general purpose policy engine. You can take OPA and you can use it at any layer of the stack in any system. And so your services can offload policy decisions to OPA by executing queries. Before we go more into OPA, I'd just like to mention something around OPA's community. OPA was founded in 2016 at Styra, and the goal of the project is being to unify policy enforcement across the stack. One of the earliest adopters of OPA was Netflix, and they use OPA for authorization over their HTTP and gRPC APIs. And there are more than 20 companies who are using OPA actively in production for use cases such as admission control, authorization, risk management, data protection, and so on. OPA was recently promoted to the incubating stage at CNCF. We have more than 59 contributors on Git. We have a healthy Slack community of more than 800 users. And just to give you some context, at the beginning of the year, we had around 400 users. So it's great to see OPA grow and people using OPA. And so just to give you a brief of what OPA actually is, imagine you have a service. And this service can be anything. It can be your Kafka. It can be your authorization service, your API gateway, your Kubernetes API server, absolutely anything. And so whenever this service gets an incoming request, it's going to ask OPA whether this query is allowed or not by executing a query. And so this query can contain your input method, your path, your request, basically any JSON value. And then OPA is going to evaluate this query based on the policies and the data it has access to and send a decision back to your service. And this decision can, again, be any JSON value, allowed, denied, true, false, any JSON value. And so the whole point here is that we are trying to decouple the policy enforcement from the decision making. And so to OPA, it does not matter if you're doing Kafka, HTTP APIs, SSH, sudo. To OPA, it's all just data. And that's why we say OPA is a general purpose policy engine. Just to give you a quick recap of OPA's features, at the core of OPA is a high-level declarative language called as Rego. And so with Rego, you can answer questions such as, can X do operation Y on resource Z? Or what fields is a user allowed to see? So with Rego, you can get more than just Boolean, allowed, denied, true, false kind of decisions. You can get decisions which are collections of values. OPA is written in Go, and you can embed it as a library or run it as a sidecar or a host-level daemon. It's designed to be as lightweight as possible, so all the policies and the data that you need are kept in memory. And it does not have any runtime dependency, so it doesn't need anything like an external call to do a policy evaluation. OPA can obviously be expanded to talk to external services for getting policy and data. It can upload its status logs to external servers, and also its decision logs, the decisions that it made, the rule that was queried, and so forth. All this information that can help in auditing and debugging, OPA can upload this to your external servers. And so finally, along with the core policy engine, OPA provides a rich set of tooling that you can use to build and debug your policies. We provide you a unit test framework, which you can use to test your policies. We also provide you an interactive shell to write queries, as well as integrations with editors like VS Code and Vim. And so just how does OPA actually work? Now, we've seen this figure before. Your service gets a request. Your service asks OPA whether it is allowed or not. OPA will evaluate the request based on the policy and data it has access to and send a decision back to your service. And so now imagine you wanted to enforce a policy in English which said that employees can read their own salary and the salary of anyone they manage. So now they're going to take this policy in English and try to implement in OPA by writing some Rego. And so like I said, when your service asks OPA for a decision, it needs to provide some kind of input to OPA, like your method, your path, or the authenticated user who makes the request. And so now let's take this policy and try to write some Rego to implement this policy in OPA. So to do that, to help you get started with OPA so that you can write more policies, today I'm going to give you 3 steps to getting started with OPA. I like to call them the 3 steps to OPA. And so step number 1 is you clone the OPA repo. So all you have to do, you have to go to github.com/open/policyagent/OPA, and you just clone the OPA repo. Simple, step 1. Once you've cloned the repo, you just build the OPA binary. So basically, go in the directory, do a make build or a go build, and that will generate for you a beautiful OPA binary. And lastly, you simply run the binary. So once you go to GitHub, clone OPA, then you build the binary, and finally, you run the binary, you are going to get an interactive shell which you can use to write queries and which you can use to experiment with OPA policies. So it's that simple. So just with these 3 steps, you can get started with OPA literally right now and start writing some Rego policies. It's that easy. Seriously. And so, can we do better? Like, this is OK. Like, this is good. 3 steps are easy. But the question is, can we do better? And so answer again is yes. So recently, we released a Rego playground, which you can use to write an experiment with Rego policies. It's available at play.openpolicyagent.org. And you can use the playground right now to start experimenting with Rego policies. So this is how the playground looks like. You can immediately see some syntax highlighting for Rego core, which makes it easy to read your Rego as well as to debug your Rego policies. And so the example we were taking before is that an employee should be able to read his own salary. And so the way you read this policy is that allow is true if input.method is get and input.path is salary employee ID and input.user is employee ID. And so the cool thing about this policy is that the employee ID value is going to be bound from a value from the input. And so the way to give an input to this policy is simply by clicking the input button. So here I have preloaded an input to this particular policy. And so the question I'm asking here is, can Bob see his own salary? And to evaluate the policy, you simply click the output button. And the answer is yes, Bob can see his own salary, which is what we wanted. Now imagine Alice is curious about Bob's salary, and she wants to see Bob's salary. So if Alice wants to see Bob's salary, is that allowed? Can Alice see Bob's salary? The result is false. So Alice will not be able to see Bob's salary. And the reason is because the expression on line number 8 is going to fail because the user making the request is Alice, but the employee ID variable gets bound to Bob. And now let's imagine that Alice gets a promotion and she becomes Bob's manager. So the second part of our policy said that a manager should be able to see the employee's salary. So you need to tell OPA this new information about Alice being Bob's manager. And so you can imagine this information being stored somewhere in your LDAP server, and you can pull that into the policy and use that as a context to your policies. So in this case, just for demo purposes, I'm just going to hard code this information in the policy itself. So I can say something like managers, and let's say Bob's manager is Alice and Fred, and let's say Alice's manager is Fred. And so now we need to simply extend our policy to make use of this new information. And so what we can say is managers. So now the person making the request can also be a manager of the person whose salary is being queried for. And so if I have typed correctly, if I again ask the same question, can Alice, who's Bob's manager, access his salary? This time, the result should be true. So Alice, who's Bob's manager, can now access his salary. So in this way, you can take a simple policy in English and write a simple Rego code to implement or enforce that in OPA. And so one of the cool things of the playground, it lets you evaluate certain sections of the policy. So for example, if I only want to evaluate the allow rule, I can simply select that and just evaluate that, and the result is true. And so now that we've written our first Rego policy, let's share this policy with friends and family. And the playground allows you to do that using the share button. It gives you a link which you can simply copy, and you can share with anybody you want to. But before you do that, let's see what's in the link. So when you go to the link, you see the policy that you wrote, which is what you expect, and that's good. But there's more. If you click on the input, you'll also get the input that you had provided to the policy. And so now, again, if you evaluate the same policy, you should get the result as true, which is what we expect. And so I hope you guys now use the Rego playground to experiment with Rego policies and share your policies with the whole world. So this figure just emphasizes the fact how OPA can be used with all of these systems and why it's a general purpose policy engine. And so the cool thing here is that we have integrations with each one of these systems, and you can start using them out of the box without having to write even a single line of code. And so now, let's look at the data protection use case. So like I mentioned before, Ceph is a distributed storage system. It provides object, block, and file system storage in a unified manner, and this is a high-level architecture of Ceph. And so what we are going to focus on is the RadOS gateway, which is basically a gateway which allows access to users and applications to Ceph Storage Cluster, and how OPA is integrated with this component. And so the way the integration works is that when a user asks for access to a specific bucket, that request will go to the RadOS gateway, and the gateway will again ask OPA whether this request is allowed or not. And in this case, that request will contain the user making the request, the method name, and the bucket name that the user is trying to access. And so OPA, again, is going to evaluate this query based on the policies and the data it has access to, and send a decision back to the gateway. And depending on if it's an allow or deny, the data will then be fetched from the object storage. And so again, here the high-level goal is the same, that we are trying to decouple the policy enforcement from the policy decision-making. And so now let's say we have this policy that we want to enforce in Ceph. It's a location-based policy which says that users can access only those buckets belonging to the same geographical region as them. And so now let's see, we're going to go back to the playground and see how we've implemented this policy in Rego. So the first thing you see is that I've hard-coded the user's location in the policy itself. But again, this is for demo purposes. You can imagine this information being stored in Git, your LDAP server, or anywhere else in the world. And so what I'm saying here is that Alice belongs to UK and Bob belongs to USA. I've also hard-coded the bucket location in the policy itself, and I'm saying there is a super secret bucket which is located in the USA. And so let me emphasize again that all this information can be given to OPA as external context. It doesn't need to be hard-coded in your policy. And so if I give an input to this policy which says that Bob, who is from the USA, wants to access a bucket called the super secret bucket, which is in the USA, is he allowed to do that? And again, if you evaluate this policy, if you evaluate this rule specifically, you are going to get a value true, which means Bob is going to be allowed to access the bucket, super secret bucket, which is located in the USA. But if you try to do this with Alice, so if Alice makes a request to access a bucket which is located in the USA, hopefully OPA's policy should kick in and prevent this request from going through. And so now if you evaluate this query, the result should be false, because obviously Alice does not belong to the US, and so she can't access any buckets located in the United States. And so again, we've taken that policy in English and we've converted it into Rego code using such a simple Rego code. And so what we've done is we've taken this entire integration and we've converted this integration into a step-by-step interactive tutorial, which you guys can try on by going to this specific link. And if you go to that link, you will not just find that Ceph tutorial, but you'll also find a cool admission control tutorial with Kubernetes, which you can try out as well. So you simply you start the scenario, and you can go step by step to the entire integration and try out how we can authorize requests using OPA and Ceph. So I encourage you guys to try it out later. And so this is what we started with. We said data is king. We said data is everywhere. It's super critical, it's super sensitive, and it's really important. And so data security is of a big concern, and it's a really important thing that you need to address. And then we saw how OPA, the open source general purpose policy engine, can provide a framework which can do uniform policy enforcement across the stack in multiple systems. And so I hope at this point we can update this figure a little to replace it with our favorite policy engine, the Open Policy Agent. And so thank you so much for listening. And if you guys want to learn more about OPA, please check out the Styra booth. You can come there. And more importantly, if you guys want this special edition, really cool OPA shirt, please stop by the booth. And if you have any questions, I can take some questions now. Thank you.
Hey, so what was the thinking behind using a domain-specific language instead of like a subset of Python or something that's sort of well-known? And I guess the follow-up to that is, what's the library support? Like, could you call out to like a Kafka queue from a policy?
So the first question was why you can't just do this in code, not like in a programming language?
Why make the DSL?
Right. So you have so many systems, each having different programming languages, and then you're trying to express these policies which are completely based on deeply nested JSON structures for these various systems, and then you have users who have to interact with these systems and learn these different languages to enforce policies in all these distinct systems. And so what OPA does is like it tries to uniformly enforce policies in any system. So you do not need to go into specific languages and learn specific ways to enforce policies which only apply to that specific system. It gives you a generic way you can do this for anything. And so imagine if you are something like a security operation person, you don't have to go and learn the details of all your services, which may be written in Go, Python, Java, and all these languages. You can simply write your policies using a unified framework like OPA. So that was the motivation behind not using a programming language and developing an old DSL. Second question was about, can you make a call from the policy itself to Kafka?
Yeah,
The libraries, so we do have, so like OPA is written in Go. So you can embed it into your Go code. That's one option. And as far as the support for making calls, you can make calls from the policy itself. So we have an HTTP send command, which you can use to make calls externally from the policy itself. We don't recommend doing that because it's experimental right now, but there are ways you can do that.
I have two questions. The first question is, can you talk a little bit about how policy is being pushed to the agent that you're going to put in the host? Like, is there any, like when I update my policy, right? Obviously, I want to make sure that my policy works in the production environment. Is there a way to do the canary or dark launch for the policy in the agent?
So the question is, you deploying your policy in production, how do you make sure it's actually doing what it's supposed to do? Is that the gist? OK, cool. So with OPA, we provide you a unit test framework. So like with any programming language, what we always recommend is before you deploy your policies in production or in Kubernetes for application control, you can first unit test your policies thoroughly, and only then you should go and deploy them in production. So we provide a really cool unit test framework, which allows you to mock out a bunch of things in the policy, and we recommend you to do that before going into production. So that would be our recommended approach for that.
You've got to follow up.
Yeah, well, I guess the scenario is if you have, like, say, 10,000 nodes, right? Like, can I push my policy to just 1% of the nodes? See, you always prepare for the worst.
So can you push, the question is, can you push your policies, if you have 10,000 nodes, can you push them to specific nodes? That's the question. OK, so there are multiple ways in which you can push policies into OPA. Like you can have OPA talk to your external service, and it can pull policies from certain endpoints. Or because OPA does not provide, it provides you APIs for the control plane. It does not implement the control plane yourself. So that is a responsibility for the user, and there are commercial options like Styra which do that for you, provide you the control plane. And so there are and the other option is using REST APIs. If you develop your own system, you can push policies into specific OPAs that you want as per your use case. So there are multiple ways you can do this.
Hi, thank you very much. What would be the general approach for using this with Ceph-FS? I think that example was using the Ceph object store, right? Is it quite generic in the sense that you could use the same principles to use the open policy agent with a Ceph-FS for using Rook, for example?
With what?
So if you had Ceph-FS
OK.
And you wanted to do policies around that instead of the object store, what would be the general approach?
So the approach is pretty constant. You're always trying to decouple the enforcement from decision making. So like in the case of Ceph, the RAD OS gateway made a call to OPA. OPA made a decision, sent it back to the OS, RAD OS, for enforcement. The same principle will apply even for Ceph-FS. The agent, or whatever is the server which is running the agent, Ceph-FS agent, is going to make a call out to OPA. OPA will generate a decision back to your FS, and then you can authorize the access to your file system. So the principle remains the same, irrespective of your system.
Is there an adapter available for OpenID Connect or JAW tokens to read the identities out, or to scopes from access tokens, for example?
Can you please repeat the question? I couldn't hear.
Yeah, the identities, if I have an identity token from OpenID Connect, can I somehow integrate that with OTA or with an open policy agent? Or how do I get the identities of an identity token into the system? Is there a connector there? Because normally I have an authentication solution which provides me OpenID Connect token, or JOT, essentially.
So the question is, how does OPA handle identities?
Yes.
In a way? OK, cool. OPA has support for JOT tokens. So if you give your JOT to OPA, OPA is going to decode that and take the claims out, and you can make a policy based on the JOT. We have support for that. Also, OPA has support for X509 certificates. So even if you give the certificate, you can make a decision based on the SAN in the certificate as well. So there are ways you can handle identities in OPA. Other option could be you can connect OPA to your LDAP server, fetch it from there, and use that as well as for identity of a user or whatever.
All right, maybe one or two more.
Yeah.
Thank you for your talk. If you had a policy where someone requests access and they are able to access under two different options. Let's say they are both, you have two claims through which they could gain access. Is it possible for audit reasons to see which claim granted them access ultimately?
I couldn't understand the question, I'm sorry.
If I write a policy that says I can access my own salary and I can access the salary of anyone, below me in the company or including myself, then maybe there's two ways I can gain access to the salary. Can you show which policy was triggered or which one causes a result to occur? Because in the example you gave, you just had result true. You weren't able to say why that result was true.
Okay. So yes, so the example I gave only showed you a Boolean response, but OPA can return to you any kind of JSON value. So you can make policies around that which say, okay, why a certain policy worked and return a specific response as per that match. So yeah, depending on how you write your policy, you can return a specific reason why the policy, which policy was applied, or you can work through that for sure, because it supports any random JSON value as a decision.
I have a couple of questions. One is there any way to manage or to identify conflicts? So I can create policies. I'm a human being. I make mistakes. And there are conflicts. Is there any methods of managing conflicts?
Okay.
And the second question is, I'm guessing all of the policies are kept on a file, right? Like it's a file with all the different policies. Is it kept encrypted? What is preventing a potential attacker from adding rules, putting a line at the top which is all allow or something like that?
Okay, cool. So the first question was, how do you handle conflicts? So the Rego language itself is very expressive, and it allows you to make a decision on that. So you can say something like your denies are going to override your allows. So you can have those kind of rules which you, as a user, can enforce in the policy. And also, we provide you like an else keyword, which gives you an ordering for your statements. So it's wholly up to the user how they want to resolve conflicts in the policy. OPA is very flexible in that way. And so the second question was, if there is policy in OPA, what's stopping somebody from just going in there and changing the policy or deleting the policy, right? So that's possible too. You can lock down the OPA agent using TLS and using a startup authorization policy, and you can only allow certain users access to certain paths and certain policies within OPA. So you can enforce such kind of security policies on the agent itself. So yeah, there are options for that too.
All right, we are out of time, so let's go ahead and thank the speaker.
Thank you so much for coming, and